discussion. So last time we end up of the 7 SI units, so discussing about them and what their effects and what are their usage. Okay, so basically, those 7 are the fundamental basic units for putting some prefixes or suffixes to those different magnitudes that represent values sa, hindi lang naman sa mathematics, also in physics and other measurable quantities. Yung kasi pinaka-goal nila, we need now to put a measurement unit to those physical quantity. So those physical quantity may be in terms of speed, in terms of mass, in terms of how long, in terms of length, di ba? So marami. Maraming mga physical quantity na mini-measure tayo at we are representing their units into those 7 SI units. Okay? So for the day, we're now going to discuss scalars and vectors. So as you all know, guys, meron kayong physics subject today, okay? I actually this semester, so magkakaroon kami ng parang konting banggaan yan. So sa physics kasi, mas broad kayo dyan actually. Sa physics 2, physics 1, 2, 3. So sa engineering mechanics, dadaanan pa rin naman natin sila. Though hindi ganun car-broad as compared sa mga yun. Doon kasi guys, yun yung mga, baka isipin nyo yung mga magda-dot product pa kayo, di ba? So, no senior high, yun yung mga medyo madugo, may dot product and cross product, di ba, ng properties ng mga yan. So, doon yung mga yun. Meanwhile, dito guys, kukunin lang natin yung concept nila because we're now going to deal with forces. Okay? To be specific mga vectors. Okay? So, now, let's start by differentiating the two. So, scalar quantities versus vector quantities. So when I say now scalar quantities, so basically now, the scalar quantities or sometimes known as scalars are those quantities which have magnitude only. So this is the magic term here. So when I say scalar, we are now pertaining to those values or magnitude. Yun lang yung bine-pair niya, such as what? Length, mass, time, distance, volume, density, temperature, and speed. For example, sa length natin guys, 5 meters, okay? So the magnitude there guys, pag sinabi natin magnitude, so gaano kalaki or ano yung certain value na yon, okay? So the magnitude there is 5 and the unit for length is meter. So when I say scalar, so yun lang yon. So 5 meter lang siya ngayon. Meanwhile in mass, kilogram. So let's say 5 kilogram and then time. So yun yung mga properties of scalar. So they don't bear any direction at all. So sinasabi lang para general information. For example, yung pinaka-famous ito si speed. For example, sinabi mo you're just traveling 6 meters per second. So that is just a normal speed. Pero magkakaiba na yan kapag yan ay nagkaroon ng direction. It will become velocity. Okay? So ano pa sir? So mostly saan ba ginagamit yan? So mostly ginagamit yan sa mga measuring in which wala namang kailangan ng direction. And also sa everyday life niyo mostly po para mga purong mga scalar yung ginagamit nyo. Such as ang mga ito. So why do we need now to introduce another measurement quantity in which a vector? So for example, guys, you try to visit a certain okay, sige, sure. You restart it. Okay? So for example, guys, you're now going to measure the distance between your home and your, like for example, home ng crush mo, home ng best friend mo, home ng girlfriend mo. So what are you going to say now is, ang bahay ko is like 50 kilometers from your house. Okay? Sinabi mo ngayon sa girlfriend mo na 50 kilometers lang yung layo ng bahay mo sa akin. And then, so that is in terms of scalar ngayon. So bakit natin inintroduce yung vector? So oo nga naman guys, sinabi mo sa girlfriend mo na 50 kilometers ang layo ng bahay mo mula sa kanya. Pero guys, if you're going to instruct her properly, did she able to get the information correctly? No. For what reason? So guys, kapag ikaw ay nagsabi na 50 kilometers from sa inyo guys, so what is now the orientation of that 50 kilometers? When I say orientation, so excuse me for a while, so i-connect na natin tong si magic ano ko. Dito, magic. Pen tablet ba to? Okay, so connect ko lang. Okay, alisin ko lang to. Okay. Tayo ay magda-drawing. First time kong gamitin to guys, baka sabihin nyo, is it? Okay. Wait lang guys, open ko lang yung whiteboard. Okay. Nag-load lang. Present now, your entire screen. Okay, ayan. Got it. Kung ang na ba? Okay. So, ayan. Wait lang. Delete ko lang yan. Okay. So, for example, guys. Ito yung bahay mo ngayon, di ba? Okay. So, for example, the scalar, guys. So, when I say scalar, so those are scalar. Okay. So, whenever we say scalar, for instance, this is now your house. Ito yan. Ito ikaw, di ba? And then, sinabi mo is that you're now 50 kilometers. Pasensya na guys, hindi ako sanay gamitin to. 50 kilometers. Actually, vector na yun kasi may distance. Don't mind the arrow, no? Okay. So, you have 50 kilometers to your girlfriend or someone. So, in terms of scalar now, you just provided now information of the magnitude in terms of length. Meanwhile, in vector, you will now provide in a such way that it will now give an orientation, nasaan in direction. Because that 50 kilometers now maybe here, or maybe here, or maybe here, or maybe here. Hindi natin alam kasi scalar only bear magnitude. When I say magnitude, that's specific value. So that's why we introduce another measurement quantity which is called vector. The vector quantities, or sometimes known as vectors, are those quantities which have both. Okay, so basically both magnitude and direction. So basically, such as what? We have force. Okay, so nag-transponding, no? So we have force, we have displacement, velocity, acceleration, momentum, and such and such. So, ito, okay. So basically, kapag nabanggit natin force, natural lahat yan ay vector quantities because they have an orientation now where will that be force directed. For example, guys, here in our drawing, so an example of force that has a orientation is, for example, you're now standing on a plane. Wait lang. So you are now standing, ayan, somewhere on the earth, and then ikaw ay nakatapak sa magic earth. Ayan, okay. So there is now a force that is being acted on you because nakatayo ka sa earth, di ba? Hindi ka out of balance, and that is what you call the weight, di ba? And at some point, there's now a force that tend to you to not to be slipped down or what. So that is the normal force. Okay, so i-discuss pa natin yan further. So this type of forces now, to be specific, this one and this one now has a sense of direction. Yung isa pababa, yung isa ay pataas. Sir, bakit iba yung alam ko? Yung ibang box kasi, sir, yung normal force nasa taas, yung weight nasa baba. Galaw din yan, guys. This is just a law of equilibrium, ay transmissibility. No? So pwede mo kasing extend sa baba yan, isa extend mo sa taas. But then and again, so ang point ko dito, these are vectors. Forces are vectors in which they provide magnitude. So may certain value to. So itong weight na to, tsaka normal force. And also, they bear direction. So isa pataas and pababa. And for example naman, tinulak ka ng kaibigan mo. So there will be now a parallel force applied here. Or kapag hinila ka naman, tension force. So those forces now bear the magnitude. For example, guys, nabanggit ko kanina temperature. Or for example, ano to, thermometer. Ay, pasensya na guys, hindi tayo marunong. Okay? CAD na lang, CAD na lang. For example, yan ay thermometer. Okay? Is a temperature scalar or vector? Ano nga ulit yung temperature, guys? Scalar or vector? Hello, guys. If you're going to measure temperature, scalar yan o vector? Hello, hello?
Scalar po, sir.
Scalar po.
Sabi ng iba, scalar. Oh, kumakain siguro sila kaya hindi sumasagot. Okay, good. Ang temperature, ito. The temperature is a scalar in nature. Pero for example, sinabi ko ganito, the temperature dropped by 2 degrees Celsius. Ano to ngayon? Sabi niya, the temperature dropped by 2 degrees Celsius. Is this still scalar or vector? Guys, kapag sinabi ko the temperature dropped by 2 degrees, okay, this is now a, sir, out muna po ako, naglolo ko po ako, data ko. Babae yan data. Okay, so, bari kasi guys na yung mga ibang scalar maging vector sila by adding some orientation into it. Okay? Pero guys, for example, sinabi ko lang, the temperature changes by 2 degrees. Scalar pa rin yun. Pero pag sinabi mo, the temperature increases by 2 degrees, so may certain direction ngayon siya. It changes by increasing 2 degrees. Nagkaroon ngayon ng direction yung magnitude mo. Okay? So therefore, it will now become a vector. Okay? So next. So there are now different important features that you can relate with a vector quantities. First and foremost, on how do we represent a vector? So a vector is represented by a directed line. It may be noted that the length OA represented by the magnitude vector OA from 0 to A. Okay, guys, marami minsan nagtatanong sa inyo, minsan ganito. Okay, so drawing lang tayo ng coordinate dito. And then we have now here a vector. Let us say, ang pangalan yun A. So how do we write vectors again? So we put the arrow on the top. So pertaining now, this has now a certain direction. And then paano natin sinusulat ulit yan? So basically, ang sabi dito guys, when you now have vector A to represent that vector in terms of length, so this will become OA. So paano naging OA, sir? So basically, kapag ganyan, anong ibig sabihin yan? Bakit saan nanggaling yung O na yun? Guys. Saan nanggaling O na yun? Ayun. Di ba meron tayo dito? Minsan magiging ano yan? Kung X lang yan, guys, for example, ito, vector X lang to. Vector X. For example, itong sa dito, magiging OX. Then yung isa sa taas, OY. Bakit? Yung O na yan, that stands for what?
Origin.
Good, that is origin. Kasi guys, maraming tataka sa akin, sir, wala naman letter O dati, tapos bigla nagka-letter O. So, ito, origin. Okay? So, kasi guys, sinasabi lang nila initial point papunta doon sa certain vector na yun, kaya nagkakaroon ng O as representation for the origin. Okay, malilito guys ha, letter lang naman yung to represent the origin. Okay? So, yun, ganun tayo mag-represent ng mga vectors. Now, unit vector. A vector whose magnitude is unity is known as the wala naman nag-join, no? Is known as the unit vector. So, ibig sabihin lang, so, when you say unit vector, guys, yung magnitude niya is 1. Yun lang yun. Okay? So, for example, ito. So, drawing ko kanina. So, if you have now here a coordinate quadrant and then gumawa ka dyan ng isang vector, so, kung value natin is 1, ang tawag sa kanya is unit vector. Kapag ang kanyang value is just 1. May nag-join ba? Ba't parang may narinig ako? Okay. So, next. Ba't pinag-join? Okay. Okay, next. So, for the equal vector, so the vectors which are parallel to each other and have the same direction and equal magnitude are known as the equal vector. So, basically, guys, parallel. So, basically, when we say parallel, guys, so ito, medyo madugo yung love story ng mga yan, di ba? Compared with perpendicular. So, for example, now, wait. I have now here a Cartesian. So, wait. We have the Cartesian coordinate system. Okay, so when we say parallel vectors, for instance, we have vector 1, then we have vector 2. So, they have the both magnitude in nature as indicated here. Parallel to each other, have the same direction and equal magnitude. So, maring ito, for example, sabihin natin 3A, so this should be also 3A, or pwede mo i-represent it as another variable. So, these are now the type of lines in watch. Diba? As definition by the parallel, so parallel lines are lines that doesn't meet, diba? So, they are parallel in each other. Congruent sila in nature. Meanwhile, perpendicular, so those are the type of lines that what? Intersect once but never going to be met again. Okay? Pero pag asymptote naman yan, like sa mga parabola, okay? So, bigyan ko lang kayo ng konting idea. So, kapag sa mga parabola, guys, asymptotic lines naman yun. So, those are type of lines that what? Yan po ay aabot at some point, magiging close sila nung line na yon, pero they will be never ever be together. So, anong mas masakit? Like yung buhay ba ng parallel o itong mga asymptotic lines na to? So, bahala kayo. Pero para sa akin, doon ako sa perpendicular, di ba? You got the chance to meet them once. Okay? Okay na yon. And then afterwards, bahala na kayo. Mag-iwalay na kayo. Okay? Next. So, we have now like vectors. Unlike equal vectors, these are also parallel but have sense but unequal in magnitude. Okay? So, sabi naman dito, pag daw like yung mga vectors, okay, they are parallel. Okay? But they don't bear the same magnitude. Ang tawag dito, like. Okay? Same ang kanilang direction, okay? But magkaiba yung magnitude. For example, ito, vector A, like, ang value niyan is 3A. So, dito maaari maging 2B. Meron din tayo tinatawag na unlike. So, kapag unlike, so kabaliktaran naman yan. So, for example, ito, this is, let us say, 2A. Kapag naman unlike, guys, they are also parallel, but, okay, they don't bear the same direction. Like, for example, this is just B. Okay, 1B, sige, 1B. Okay? So, these are unlike vectors. So, opposite naman siya ng like. So, kapag like, those lines are parallel in nature and at the same time, they bear the same direction but just different in magnitude. Meanwhile, in unlike, they are both parallel but unlike in direction. And syempre, hindi same na magnitude. Okay? So, next, we have addition of vectors now. So, how do we add these vectors out together? Okay? So, dito tayo. For instance, we have now an example here. So, we have vectors PQ, so, and RS. Okay? So, these two vectors now are going to be add up. Therefore, ano ngayon ang gagawin natin in order for us to conjoin these two? Okay? So, there are different methods in adding vectors. And at the same time, subtracting two vectors. So, we will be going to discuss them later. Okay? For instance, take a point A. So, sir, what do you mean by this point A? So, sulat muna natin yan. Sabi nila, meron daw dalawang vectors. So, ito, we have vector 1. So, we have vector 1. We have vector 2. So, the first vector daw is PQ and RS. So, this is... actually, mali pala, no? So, hindi pala sila magkadikit. Sorry. Hindi all the time magkadikit yung mga vector natin, ha? So, we have vector... Ito. So, we have vector R, and then we have S, and then we have vector P and vector Q. So, how do we add up these two? So, you have no idea kasi nagduman kayo ng physics during your senior high. So, yung mga alam niyo so, siguro nung bata kayo like parallelogram method, triangular method, or such method. So, let me just refresh them. So, for example, dito sabi niya, ang gagamitin natin is the addition of vectors. Okay, so we're going to apply the addition of vectors, mostly yung triangular method. So, take point A. So, basically, ito point A na to, and draw line AB. So, sabi niya, draw line AB, in which now, yung line AB na yun now is now equal to the magnitude of vector PQ. So, ito daw, i-represent lang natin, itong buong vector na to, guys. Itong buong vector na to, we're now going to represent daw to another vector in which ang pangalan naman niya is A and B. For example, ito. So, we have vector A, B. So, ayan, vector A and vector B. So, ito guys, same magnitude. Same magnitude, itong dalawa. Imagine na lang, pero in physics, guys, huwag kayo mag-drawing ng ganyan, ha? So, dapat pantay talaga sila in measurement. Kaya nga, di ba, same magnitude, okay? Next, through B, draw BC and equal to the vector RS to the same scale. So, ito daw, itong RS naman, i-represent naman natin siya by another set of vector, but this time, you're now going to connect it to B. Okay, so what will happen now? So, i-delete natin muna yan para malinis. Okay, so we have here our vector AB. So, ito yung representation ng P and Q kanina. Ngayon daw, i-represent naman natin si RS by BC. Okay? And the sabi na, you must connect it to sa last tail. Last head. So, we have tail and we have head here. BC. Okay? So, these two now are the representation only of PQ, vector PQ, and vector RS. Okay? So, how do we add now those vectors? So, paano ba mag-add ngayon ng dalawang vectors? So, basically, by law of additions, all you have to do is PQ, vector PQ now, plus vector RS. So this is now equals to a certain vector in which ano papangalan mo vector ngayon. Sa illustration now, this will what we call now the resultant of a certain vector in which it can be solved by what? So this is called the triangular method in solving vector addition. Why? Sir, baka siya tinawag na triangular method. So basically, ito ay nag-form ng triangle. So later kasi guys, mamaya, mag-solve naman tayo via means of what? Parallelogram method. So there are so many ways on how to solve that. Sir, paano sasagutin yan? Madali lang. For example, ito may value na 3. Ito may value na 2. Edi 3 plus 2, edi 5 yung value. Pero gano'n lang kadali sana yun kung yung triangle is ordinary, di ba? Kung right triangle lang yan, like 3, 4, 5. For example, 3, 4. Then yun magiging 5. Okay? Pero unfortunately, hindi siya gano'n kadali. Okay? So the method of adding, ayan, adding of two vectors is called the triangular law of addition vectors. Similarly, if more than two vectors to be added, the same way may be done first by adding the two vectors and then adding the third vector to the resultant of the first two, and so on. The method of adding the two vectors, the polygon law of addition of vectors. So, ito yung pinaka-main name ng solving natin. For example, tatlo daw. Tatlo. For example, meron kang certain na another vector dito. Since may ares na tayo dito, may peak, ano ba maganda? KA na lang. So, para pangalan ko. Ay, hindi. A na pala yun, A. A. So, A, C. So, D na to. So, this is vector D. So, kapag isolve mo ngayon, yung resulta na tatlong yan, so, etong dalawa guys, etong dalawa dito, ang magiging new values nila, itong resultant na ito. Okay? So, para makuha ulit yung bago, so we're going to add both of them again. So, ito yon. So, magkakaroon ng panibagong resultant dito. Okay? And so on and so forth. Okay? So, marami yan. Maraming solving tayo na pagdadaanan na puro ganyan yung orientation. Ang kailangan nyo lang tandaan, how do we add them, how do we combine the magnitudes, and konting knowledge lang naman sa math. Okay, so for example naman, subtraction of vectors. So how do we subtract? So basically, it has now the same property on how do we add two vectors. Okay, so ano lang ang pinagkaiba? So gagamit lang tayo ng subtraction. But take note of this. For example, guys, you try to subtract what is 10 minus 2. Ano sagot, guys? Guys, what is 10 minus 2? Hello, what is 10 minus 2?
It's 10.
Natutulog na ba kayo, ha?
8.
What is 10 minus 2?
8 po, 8.
Ano, 12 o 8? Siyempre, dalawa lang yan, guys. Kung manghuhula ka, 12 tsaka 8, di ba? Pero kung babasahin ko yan, ano yan? 1, 2. 0 ang sagot dyan, guys, kung babasahin ko. Di ba? Sa binary, this is 1, this is 2. So, 2 yan naka-on. So, 2 minus 2 is 0. Hindi, wag yung tandaan yan, guys, ha? Sa programming yan. Okay? So, sabi dito, for example, you have now 10 minus 2. So, sabi nyo, 8. Okay? And then also, for example, what is 10 plus negative 2? Ano sagot?
8.
8 pa rin. So, marami kasing batang nalilito. Like, for example, sir, di ba kapag vector subtraction, dapat subtraction lang? Pero di ba vector addition to? Sir, paano naging vector addition? Kasi yung operation na ginawa, addition, sir, how do you represent now negative vector? So, paano tayo nag-represent ng negative vector? So, basically, guys, nandun lang yon sa kanyang direction orientation. For example, guys, I have now here a vector B going upward. Then, how do we represent a negative vector B? Paano tayo mag-represent ng negative vector B?
Going down.
Yes, just going down. So, the opposite of that value. Tandaan nyo guys, hindi mahirap tandaan yung mga polarity because those are just orientation saan papunta ngayon yung force. Ang importante dyan guys, yung kanyang magnitude. Yung kanyang value na dinadala. Kasi guys, kahit anong mangyari naman dyan guys, magbalabaliktad man ng mundo, siya pa rin. Okay? So, yung value will still remain the same. Yun nga lang, there is some tendency that will become positive or negative in nature. Okay? Next, so ganun na tayo mag-subtract. So same process pa rin. So what do we do? So we just combine both two vectors and then we tend to directly subtract them. Okay? So let us now move now on how do we solve this kind of vector. So introduction lang yun. No? Huwag niyo akong hanapan like hindi tayo, okay mag-alala guys, hindi tayo pupunta doon sa may mga vector product, vector Nagganon ba kayo guys, yung mga cross product and then dot product? Nagganon ba kayo dati during your senior high? Sir, hindi ko alam. Like, parang natutulog lang ata ako ng senior high. Mapotential yung mga yan, guys, no? So, dapat alam niyo yung mga yan. Okay? Pero don't worry, okay? So, nandito naman ako to refresh everything na nangyari, no? So, papaalala ko yung nakaraan sa inyo. Okay? May question pala ako sa inyo, guys. Sagot nga kayo, guys. Meron akong quick question. So, we are now dealing with a branch of science, which is engineering mechanics, that is also now related to all the science branches we have in engineering. If I'm going to ask you guys, which is most favored para sa inyo? Chemistry or engineering mechanics? Sige nga, siyempre dinaanan niyo na third day, so chemistry, so nalaman niyo. Kung kayo tatanong guys, ano yung mas gusto niyo? Chemistry or engineering mechanics?
EM.
O yan o, porket ako lang yung nagtuturo ngayon, EM. Pag yan si Sir Day nagsalita, like, chemistry sasagutin niya. How about yung others, guys? Kasi nadaanan niyo yung chemistry, tapos ngayon dadaanan niyo yung engineering mechanics. Engineering mechanics is very, very different with chemistry. So sa chemistry, we're dealing with, we are naming them, we are balancing some elements like, hindi ko naman. Pero nagkaroon ako ng idea how to name them and balance them. Okay? Credits to someone like, makulit na bata. Okay? Okay, so ngayon, yung point ko doon is, whenever saan kayo na branch ng science, so mahalin niyo lahat sila because iba-iba man din yung EM sir, syempre. Mga plastic. Okay? So kahit nasaan man kayo guys, importante ang kada branch ng science natin. Okay? It may be chemistry, it may be physics, it may be engineering mechanics, it may be strength of materials, it may be some other form of sciences. Importante lahat yun. Okay? Without them, wala tayo dito. Okay? Pero the best pa rin yung math. Okay? Bully ka no? So, okay. So, saan tayo? So for today, we're now going to introduce forces. Okay, so ngayon, so tapos na tayo sa mga buhay kung saan tayo ay, same, sir. Okay. So tapos na tayo sa part kung saan pinag-aaralan natin yung mga terminologies, how do we do this, how do we do that. So this time, we're going now to apply those knowledge. So dito na mag-start yung, let us say, marami-raming solving. Okay, pero rest assured guys, okay, so baka some of you will think na na mahirap yung mga solving. Hindi, okay? So, dadaanan lang muna natin sa madali and then konti-konti tayo mag-solve ng mga bagay-bagay. Okay? So, let us start. If you have questions, feel free to ask. Okay, so, ayan, naghang na naman yung aking Google. Okay? The joke lang guys, love na love ko yung chemistry. Na baka sasabihin nyo, binabash ko yung chemistry. Love na love ko lahat yan. Hindi lang ako love kasi talagang nahirapan niyo kayo. Nahirapan ba kayo kay Sir Day nung chemistry, guys?
Yes, sir.
Mahirap, no? Batak din kasi Sir, napakagaling. Talagang saludo kay. Si Sir Day din yung chemistry namin, like, kapag nagbabalance siya, guys, alam niyo ginagawa ko, tinitingnan ko yung ballpen ko, then I am trying to balance it, di ba? So, sino mas mauna sa amin mag-balance ng ballpen, tapos siya nagbabalance sa board. And then I end up, like, fortunately, pumasa naman ako, di ba? Pero enjoy lang, no? So, dalawa pa may chemistry natin. We have chemistry 1 and 2. Okay. Naniniwala ba kayo, guys? Maganda lahat na nagtuturo ng chemistry. Sir, lalaki nagturo sa amin ng chemistry. Oo nga, no? Okay. Lugi doon. Okay, so ngayon, start tayo. So, introduction now. So, we're now going to deal with forces. So, the force is an important factor in field of mechanics. Basically, why? By definition, ano kasi sinabi natin, mechanics now is what? It is the study of body and its property. Di ba? So, how can we now identify the behavior of that body without implementing those forces? Such as, for example, if there is now a lying block of wood on a given surface, ayan, for example, meron daw kahoy dyan. Ayan, kahoy. Nakakainis. Magkakad na lang talaga tayo pag nag-drawing. Okay? So, imagine nyo guys, nakadikit yun sa nakadikit yun sa ground, okay? So, kapag yung block of wood na yan, so body, so nakapatong yan sa surface. So, there are now forces now na naka-apply dyan. So we have the normal force, we have the weight force. Okay? So that is a study of mechanics. So this is now in equilibrium. So when I say equilibrium, balance. Equilibrium. Equal yung forces applied. Pero guys, mag-iba yung usapan whenever now I try to apply a parallel force here. Bakit? The tendency now, this object will move at a given distance. Okay? So, meron na naman introduce na force dito. So, it will become now non-equilibrium. So, hindi na siya balance. And at the same time, habang gumagalaw yan, guys, there is now a certain force na pumipigil sa kanyang gumalaw. At ano tawag dito ulit? Ano symbol to? Ang pangit ng drawing mo, sir. Anong symbol ulit to, guys? Yan. Anong symbol ulit yan? Kung natatandaan nyo, that is times 10 raised to negative 6, also known as the... Anong pangalan ng ating constant na yan, guys? This is... Nag-chat na ba? O baka yun lang sa this is... wala. Sige nga, guys. What do you call this constant?
Mu.
This is mu, di ba? To represent times 10 raised to negative 6, also known as the frictional force. Frictional force. Okay? So, na-represent natin yan as mu. So, nahati pa yan sa dalawa na pag-aaralan natin, static and dynamic. Okay? So, this is now engineering mechanics. You are now studying the properties of body. Okay? And kapag yan ay in-applyan ng force. So, bakit napaka-importante ng role ng force engineering mechanics? So, basically, guys, without that force, ano pa pag-aaralan natin sa engineering mechanics? Di ba? So, wala tayo ngayong magnitude representation, gaano kalakas to, gaano kalakas yan, and such, and it such. Okay? Which may be broadly defined as an agent which produces, tend to produce, destroys, or tend to destroys motion. So, for example now, force applies force to pull a cart and set it in a motion. So, basically, meron daw kabayo na humihila ng cart. So, forgive me for my drawing, guys. So, ngayon pa lang humihingi na ako ng tawad. So, for example, we have now cart. May gulong yan. Inihila. Oh my God. How do you draw a horse, guys? Ayan. Okay. So, for instance, walang tatawa. Walang tatawa, okay? So, sabi sa example, so nahati kasi yung classification of force. It can be either what? It tend to produce, destroy. Okay? You know? Destroy or tend. So, dito, ang scenario dito, hindi destroy actually. It what? It tends the motion. When I say tends, siya yung nagke-create ngayon para magkaroon ng motion dito sa inhila niya kung anong cart na yan para gumalaw. Okay. It can also destroy the motion. For example, you try to stop something, so destroy the motion. Yun, and yun lahat ay representation ng force. Basta tandaan nyo guys, force is parang representation na tend to destroy or move. Okay? Force is also required to work on a bicycle pump. So, basically, kailangan din yon. In this case, the force is supplied by the muscular power of our forearms and shoulders. So, alam nyo ba yung bicycle pump, guys? Yung pambomba, di ba? Pambomba. Like, yung minsan kulay red yun, di ba? Don't judge me, okay? Okay, so ito. Paano ba yun? So, meron kang ano dito, parang pinapump. Ayan, so ito yung bicycle pump. So, what we do now here, ito ikaw, so you tend to apply a force. Oh, yan, lit ng tao, may kilalak ganyan. So, bibigyan natin ng buhok para mas familiar doon sa kilala. Okay, so we tend to apply force here, in which ang sabi dito, so by the muscular power of our arms and shoulder. Okay? Sometimes, the applied force may not be sufficient to move a body. Example, if you try to lift a stone weighing 2 or 3 quintals, we fail to do so. So, quintals is a very large measurement of force. Alam niyo ba, nung nabasa ko minsan, ang theoretical na kaya lang buhatin ng tao is just 1.5 times of our own weight. So, parang superhuman na yung mga bubuhat na. For example, 50 kilograms ka, nagbuhat ka ng 200 kilograms. So, medyo mahirap na yun. Okay? So, this shows that a force may not necessarily produce a motion in the body. Okay? Bakit? O yun nga, kapag ikaw ay nagbuhat ng, for example, like nagbuhat ka ng elepante, di ba? Okay, sige, ibahin ko yung problem, yung given, kasi hindi ko kaya mag-draw yung elepante. For example, I will just represent the elephant by this box. So this will weigh like 300 kilograms, di ba? So, kahit anong gawin mo, like apply ka ng force dyan, hindi pa rin yung gagalaw, tendency Y. So, hindi yun enough hindi yan enough yung force mo, di ba? Lagi naman ganyan, guys. There are some tendency na ikaw ay magkukulang, di ba? Kulang yung lakas para siya ay mapa-move, di ba? So, even though such, there is still unapplied force. Kasi baka sabihin nyo, sir, hindi naman gumalaw. Ibig sabihin, sir, walang force applied? No. Much greater kasi ngayon yung meron dito kesa sa'yo. Ganun naman, guys. Pag mas lamang siya sa'yo, wala kang laban. Okay? So, okay. In this case, we exert the force, no doubt, but the motion is produced. So, no motion will produce. So, no doubt doon. Try mo lang, itulak yung klase mong mataba, di ba? So, kung siya ay mas mataba sa'yo, like, for a very, very much value, hindi yan gagalaw kahit anong mangyari. This shows that the force, ito, but it may simply tend to do so. In a tug of war of the two parties when balanced, they neutralize. Okay? For example, paano yon? Nakita na ba kayo ng tug of war? So, ayan na naman, masusubok na naman aking engineering drawing. Kaya ako, guys, nagmaster ng CAD para hindi ako ay mag-drawing ng technical. Okay, para fair, this is boys versus girls. Okay, for example, ayan. So, you're now playing tug of war. Ito ay magiging neutral kapag yung force applied is equal on all sides. So, ang tawag sa force line is what? Tensional force. Though we will discuss this further. So, this is neutral in which kapag same yung forces applied. But the moment one party gets weaker, the other party pulls off in spite of the first party, the best effort to destroy the motion. So you're now going to destroy the motion kapag humina isa. For example, ganito guys. So this is now an example, parang relationship niyan, no? So a perfect relationship should have a balanced force applied. Like hindi pwedeng lamang si boy, hindi lamang si girl. So ano mangyari guys? Kapag yung isa sa inyo nang hina, for example, I'm going to use this example, no? Sir, gendering ano pa naman. So kapag nanghina si girl, what will happen? The tendency now is kapag yan ang hina, the force applied dito is si hina. Sir, bakit hindi ito? Ito kasi guys, yun yung napuproduce sa tension sa kanya. And then dito yung tension sa babae. Pag yan humina, mas lalakas yung person na lalaki. The tendency is ma-out of balance to. Hindi na siya equal. And then tendency, si boy na lang lahat na nagbibigay. Okay? Mahirap yon. Okay? So the effects of force. So what are these effects? Yan. So nalaman natin yung parang fundamental basic about force. So how about now the effects? A force may produce the different or the following effects on a body on which it acts. Guys, tandaan nyo, whenever I say body, hindi yung katawan ninyo. Okay? Well, pwede yung katawan ninyo. Pero for example, I can also say, this table is a body, the computer is a body, so different. So representation yung body, okay? It may change the motion of the body. So yun yung unang-una natin kailangang alamin kapag merong force. Kaya niyang i-change yung motion ng body. It can either what? Pwedeng pabilisin or such. For example, if a body is at rest, so hindi yan gumagalaw, so basically pwedeng gumalaw, walang change in acceleration, the force may set in a motion. Okay? And if the body is already in motion, the force may be accelerated or it may retard the motion of the body. So dalawa yan. Kapag daw hindi siya gumagalaw, so pwede tayo mag-apply ng force para ay gumalaw. Pero sabi ko nga, hindi not all the time. Di ba? At as long as dapat much greater yung force applied mo kaysa doon sa force na meron sa isang body. Okay, if the body is already in motion, it may now accelerate it or retard. When I say retard, stop. Okay, decelerate. Alam ko yung iniisip nyo ngayon iba yung iniisip ng term na retard, di ba? Sa tao guys, itong sinasabi yung retard ka, like bumabagal yung process ng utak mo, okay? So it may retard the forces already acting the body, thus bringing it unrest or equilibrium. So what do you mean by that? For example, ayan, okay, clear canvas. So when you say equilibrium, isipin mo na lang guys, ito. So gumagalaw yan guys. So magkakaroon lang ng equilibrium yan guys kapag balance yung forces applied sa kanya. Okay? Kapag siya gumagalaw, for example, from left to right, whenever you try to apply an opposing force, in order for it to become equilibrium, dapat equal yung dalawa para mag-stop. Okay, kaya nga guys, yung mga roller coaster, dinesign yan by engineering mechanics, dapat alamin ngayon ng mga designer ng mga amusement park that at some point, dapat hindi yan hihinto do sa taas. Like for example, para ma-visualize ng iba. For example, here, you have now a roller coaster, then we have a loop. So, hindi yan pwedeng tumigil dito sa baba, di ba? So, para mapa-final destination ka, okay, then mahulog yung camera. Hindi ganon. Okay, the engineer now will try to solve now the tend of force here. Okay? So, dapat hindi siya magkakaroon ng equilibrium state dito sa taas. Else, magkakaproblema ang buhay natin. Okay? ikaw ay mapa-final destination. Okay? It may give rise to internal stresses on the body. So, nakakaramdam ng internal stress. So, yan, parang higher physics na yan. Kasi guys, dito, hindi natin kinakonsider yung stress sa loob. Okay? Nakakaramdam ng stress sa body. Kahit sino naman guys, for example, try mo itulak-tulak yung bato, like pukpukin mo, di ba? Para magkaroon ng movement. So, makakaramdam ng stress yun at some point. And then yan ay mag-breakdown. You cannot see stress actually. So, sa engineering, we are measuring stress. And what is the unit of stress again, guys? Sige nga, as I recall, what is the unit of stress? What is the unit of stress in engineering? Okay, we have answers. We have chinita yung babae. Aha. I don't know. Okay. So how do you measure stress again, guys? Ano kasi unit ng stress? Naku, kinalimutan siya. Ano ang unit ng stress? Ano Pascal? Hindi, typo lang. Okay. Good. Pascal. Pascal, that is Newton per meter squared. It is same with pressure. Okay. Now, we now characteristic force. So, ito yung effects ng force, ha? Huwag niyo kakalimutan. Lastly, itong internal stress sa body. Okay. So, what are the characteristics of forces now? So, they are classified in terms of magnitude. So, ito, for example, the magnitude is 100. So, the unit is Newton. Okay. Next, the direction of the line. So, dito pag-aaralan natin. Ito na naman guys, nakita kayo ng OX, OY. So, this means now, this is from the origin to X and origin to Y. Or sometimes, pwedeng 30 degrees north of east. Okay, malilito ganyan na. 30 degrees north of east. Therefore, ito ay ganito. Pag sinabi natin 30 degrees of north, so, dito sa taas manggagaling. Magkaiba kasi 30 degrees north of east sa 30 degrees east of north. So, 30 degrees north of east. And then yung kabila, syempre, di balance yan. So, 60 yan. So, kung 60 degrees yan, ilan to? O, syempre, 30. Okay? Para maging 90. So, pag-aaralan din natin yan yung proper reading ng mga yan. Nature of the force. Whether the force is push or pull. So, eto na naman. So, malalaman natin later. This is denoted by the arrowhead. So, basically, guys, kapag ito, for example, you have now a box here. Kapag ang arrow patusok dito sa box, push or pull? Ano yan, guys? Kapag yung arrow going to the box, is that push or pull? Okay, guys. Ulitin ko. So, sabi dito, guys, nature of force, whether push or pull. So, malalaman doon is arrowhead. Kapag ganun arrowhead going to our body, is that push or pull?
Push.
Push or pull? Ang tendency, guys, kapag push, ang tendency is going inward. Okay, tandaan nyo palagi yun. Inward. Kapag pull, outward. Okay, yung force going. Okay? Kaya pag tug of war, guys, di ba yung kaninang arrow ko, papunta rito yung isa, then papunta yung arrow doon. Imposibleng papunta sa gitna yan, guys. Hindi tinutulak niyo yung lubad pa gitna. Parang kalokohan lang yun. Okay? So, principle of physical independent forces. Though, ito ay isang principle lang in which in-state na, if a number of forces are simultaneously acting on a particle, then the resultant of these forces will have the same effect as produced by these all forces. So, tandaan nyo palagi, kasi dapat yan ay maging balance. So, whenever we have a force here, dapat yan ay balance to the another force and to the resultant force. Kaya nga guys, kinukuha natin ang resultant. Kailangan natin makuha saan ba nagbabalance lahat ng forces na ito. Sir, bakit natin nga ginagawa sa engineering niyan? Guys, mostly ginagamit yan sa practical application nga na pagdidesign natin ng mga bagay-bagay. Okay, so hindi siya pwedeng ma-disregard. So, ganyan ka-importante yung engineering mechanics sa individual life. Okay? So next, so principle of transmissibility. So it states that if a force acts at any body, on any point on a rigid body, it may also consider to act at any point on its line of action. So what do you mean by that, guys? For example, ganito. Palagay ko naaral niyo na to pero hindi niyo lang alam na transmissibility ang tawag. For example, I have now here a force. Here, may force ako dyan. And then, meron din ako force dyan. Meron din ako force doon. And then, ikaw, hindi ka sanay na magkakahiwalay yung force. Ang sabi ng principle of transmissibility is, sabi niya, so let me read again, to act at any point of that line of action. So, ibig sabihin, guys, itong line natin, we can extend it here, kasi guys, yan yung kanya line of action, at madala yan dito, guys. Kapag natin nadala dito, ito mawawala, ayan. So, that is the property of transmissibility. Sir, bakit natin ginagawa yun, guys? Kapag ginawa kasi natin, mas madaling i-solve because they are just lying at the one quadrant. Mas madali. gamit natin ginagawa yan kasi ang orientation ngayon ng reference, mas madali na siyang ma-identify. Unity na ngayon ang pinanggalingan ng force. Kasi sometimes guys, there are some forces here, there are some forces there, there are some forces there, then malilito ka na. Ay, anong angle nito? Positive ba to? Negative ba to? So, medyo mahirapan ka na. So, you can apply transmissibility as long as guys, sa transmissibility, dapat nasa line of action. For example, ganito ayan, ito yung force. So, yung force ito dapat ayan lang. So, hindi siya pwedeng magbago ng angle. Kaya baka for example, 45 na siya dito. Paglipat doon guys, hindi na 45, like naging 30 na. Ay, hindi transmissibility yung tawag dyan. Kalokohan ang tawag dyan. So, pag transmissibility, line of sight. Okay? Line of action of force. Ngayon. Okay? Next, system of forces. Oh, ito na. So, siguro hanggang dito na muna tayo. So, sa system of forces. So, basically, when two or more forces act on the body, they form a system of forces. So, what are those forces? First, we have the coplanar. So, what do you mean by coplanar? So, as per definition, when you say coplanar, so these are now the type of forces in which the line of action lies on the same plane are known as the coplanar. So, for example, we have now a plane here. When I say plane, hindi airplane, pakiusap lang. So, we have now plane here. Ayan. So, X-plane. For example, X-plane. So, kapag para lang matawag na coplanar, dapat daw lahat ng force are lying on the same plane. For example, we have now vector A, vector B. Vector A and vector B now are coplanar because they are lying at the same plane. Pero guys, for example, ayan, may humilata na force dyan, naka-angle. Hindi nyo ma-visualize, no? Imagine nyo guys, ito tabla yan, tabla. Tabla to. Ito, patayo yung baksak. Ito, nakahiga. Okay? So, this is not now coplanar with these two forces because they are not lying at the same plane. Okay? Kasi nakahiga siya. For example, papunta naman dito, nakagilid. This is not coplanar. So, kapag coplanar, guys, lying at the same plane. Okay? Next. We have collinear. So, whose line of action of same line are also known as collinear. So, ito guys, ang pinakamadali. For example, now, we have a line here. So, for example, may nag-act dito na force, may nag-act dito na force, may nag-act dito na force. So, all of these guys are what we call collinear. Okay? So, they are lying at the same line kapag ikaw ay collinear. Okay, next, concurrent. The forces which meet at one point are known as concurrent. The concurrent forces may not be or may or not be collinear. So, paano naman yung concurrent? For example, now, you have here, ayan, ayan, ayan. So, for example, guys, you have now a force here na pumunta rito sa origin. So, para matawag na concurrent yan, guys, lahat ng force nang galing sa isang point. Ayan. And then, ayan. And then, meron pa tayo dito sa negative y. Ayan. So, concurrent kasi yan, guys, nakikita sila at certain point. So, sabi niya, guys, concurrent forces may be collinear or not. So, for example, merong isang point dito, dalawang points of force dito. So, linear yan. Okay? Pero this is a concurrent non-collinear. Kasi, guys, pero dalawang force dito na hindi naman nag-lie at the same line. So, yan, yung collinear. Basta nakikita sila at one point, concurrent na ang tawag dyan. Next, coplanar concurrent. So these are the forces that meet at one point and also at the same plane. So for example, ito, imagine nyo, this is x-axis. So yan ay example ngayon ng coplanar and concurrent. For example, ganito, gawa natin ng 3D. So madali sana yung buhay kung AutoCAD. For example, ayan. 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 So, nag-3D na ba kayo sa physics? So, we have X, we have, nakalimutan ko na Y ba to, and then Z. So, sa X, guys, for example, ayan, nagkita si X lahat dito. Uy, sana lahat nagkita si X. Ayan. So, ayan. So, sa point of view dyan, so, point of view dito, guys, they are concurrent at this point. And also, they are also coplanar because they are lying at the x-axis. Pero, guys, kapag yan, ayan, may tumusok yan dito sa taas, yan ay magiging non-coplanar because hindi naman lying at the same plane. Okay? So, ito yon, non-coplanar concurrent forces kapag ngayon ay nagkaroon ng angle dito. Nagkaroon ng angle. So, hindi na sila naglalay at the same plane. Ayan, for example, nagkaroon ng theta and then dito nagkaroon ng angle theta. So, hindi na sila naglalay at the same plane. So, they are not coplanar with each other. Okay? So those are now, meron pa pala, non-coplanar, non-concurrent. Sarang gulo naman yan, paano yan? Isipin mo guys, no? Meron daw type of force na hindi na nga nagkikita, hindi pa nagkakasundo. I remember someone. Hindi, joke lang, no? Hindi na daw nakikita, hindi pa nagkakasundo. For example, guys, you have now a body here. Okay? For example, may TED force dyan. Non-coplanar na nga, ano pa? Non-coplanar na nga, non-concurrent pa. So, dun muna tayo sa non-coplanar. So, for example, ang galing yan sa X, ito nang galing sa Z at an angle of reference here. So, non-coplanar na yan kasi hindi sila nag-delay. The non-concurrent. So, ibig sabihin, for example, dito nag-stop yan at ito dito. Then, meron isa pang force dito. Ayan. So, non-concurrent yung mga yan. And then, non-coplanar pa. Basta tanda na guys, pag non-concurrent, hindi sila nakikita at some point. Kapag non-coplanar, hindi sila nakikita at a certain plane. So, for example, ito galing naman sa Y at a certain angle. Okay? So, bakit importante yung mga yan? So, gagamitin natin kasi yan, guys, kapag nag-solve tayo ng forces, kapag nakita mo, collinear ito mga to, so madaling i-solve. Kasi yung orientation, isang line lang. Kapag naman coplanar, they are lying at the same plane. Pero guys, sa engineering mechanics, worry not. Lahat naman ang gagawin natin is, ayan, pag nag-solve tayo, ito. So, basic muna. So, they are lying at the same plane. So, puro coplanar muna tayo. Okay? So, that's it muna for today. And then, next meeting tayo ay ngayon magdi-discuss ng application ng mga forces na ito. Okay? So, may I request everyone to kindly turn on the camera, yung favorite portion natin na. Sorry guys, no? 1 hour na naman akong kumakatak. Di ba pinangako ko kanina like parang ano lang, ang tawag dito, parang 30 minutes challenge lang pero hindi natin nagawa. Okay? So, do you have any questions muna guys? Questions? Guys, may questions ba tayo bago tayo mag-end? May I request everyone to kindly turn on the camera for some